So this week, we should be almost done this. You have a quiz on Schoology. And I just wanted to very quickly go over what we did from last day, super quick, because that was a long lesson. Here we go. So this is the worksheet you're going to get this week, okay? And this is based on what we learned last week. And it is about compounds which are either ionic or they are molecular, okay? You know that a compound is ionic if it starts with a metal or if it starts with NH4. If you have anything else, if it does not start with a metal, if it does not start with NH4, then it is a covalent compound, okay? Molecular, covalent, anything else. Okay, so you're going to have one exercise that just asks you to identify whether your compound is ionic or whether it is molecular. And you just look and you say, does it start with a metal or NH4? If it does, it is ionic. If it is anything else, if it does not start with metal or NH4, it is molecular. Okay, so that's going to be question number 1. Question number 2, you are going to recognize your acids. Acids are molecular. They're a special type. You remember we talked about that last week? They do dissociate into ions. So you need to be able to recognize them and distinguish them from other molecular compounds. And you will recognize them because they are molecular compounds, acids, but they either begin with H or they end in COOH, like acetic acid is CH3COOH. So what you're going to do for question number 2 is you are going to circle the compounds in question 1, which are acids. So because they are molecular, you can just go find all the ones that say M, and then you can decide, do they begin with hydrogen or do they end in COOH? If they do, then they are an acid and you will circle them, okay? Writing dissociation equations for ionic compounds and acids, you have already done this. This was done 2-3 weeks ago, okay? But it's been a while, so let's just quickly review it. It means that they come apart, okay? And so the only little tricky bit is that COOH acids dissociate in a bit of a funny way. It's that final H that comes off as an H+ ion, okay, which is a little bit odd. Okay, don't forget to include your charges, your states, and your balancing. So, for example, if we have NaCl, there is 1 Na and 1 Cl, so you end up with 1 Na and 1 Cl. Easy peasy. It was ionic. How did I know it was ionic? It started with a metal. Okay. Fe2SO33. Look, iron is a metal, therefore this compound is ionic, and therefore it will dissociate. Okay, this time we have 2 irons, so that's going to be 2 Fe's. We have 3 sulfates, so that's going to be 3 sulfates. Okay, and don't forget, of course, your charges. This next one we have is an acid. How do I know it's an acid? I know it's an acid because we have an H. Okay, and it just dissociates. There's just 1 hydrogen and a single nitrate. We don't have 3 nitrates because remember, this 3 is part of the nitrate. We have a nitrogen with 3 oxygens attached. Okay, that is a nitrate ion. So it's not like there are 3 of them. There's just one of this whole thing. Okay. And then finally, these are the ones that might catch you. Just look for the COOH, okay? COOH. And remember, it's that last H that comes off when they dissociate. Okay? So those, you're going to, for question 3, you're going to write the dissociation equations. Everything in here is either ionic or it is an acid. And so they will all dissociate and they will all have ions at the end. Now remember, molecular compounds do not dissociate. They instead undergo dispersion or dispersal. Dispersion, dispersal. And these are for the molecular compounds which are not acids. So that's anything that does not begin with an H, which would be an acid, anything that does not begin with an H4, or a metal. And these are the ones that are like super, super easy to write. Remember that the molecules stay intact. I don't know if you remember this one from last week. We had I2, which was a solid, and then it dissolved in water, and you got I2, which was aqueous. Okay, so all you're going to do is you're going to take the molecule, and instead of being a gas or a solid or whatever, you're going to write that it is aqueous. But the formula does not change because the molecules stay intact. So really, question number 4, where you're writing the dispersion, these should be really easy. You're basically just rewriting the compound and writing aqueous afterwards. Finally, recognizing electrolytes. Remember, electrolytes have free ions, and non-electrolytes have no free ions. So substances that conduct electricity in solution are called electrolytes. Solutions that contain ions can conduct electricity and are called electrolytes. Solutions that do not contain ions cannot conduct electricity and are non-electrolytes, because in order to conduct electricity, you need charged particles that can move. Okay. And so your soluble ionic compounds and acids which dissociate into ions are electrolytes. Molecular compounds, which are non-molecular non-acid compounds, don't dissociate. So if we look at just a little quick picture here, we have our dissolved sodium chloride here. And you can see we have positive and negative ions. And in the dissolved sugar, the solid form, all of these individual sugar molecules would have been all clumped together in a solid crystal. This would be a sugar crystal. But in a solution, they have been dispersed. They have been scattered, but they are not split into ions. And so there are no charged particles. Okay. And then just finally, why does that make them electrolytes and non-electrolytes? Well, oh, why did that get so big? There we go. Medium size would be good, medium. In an electrolyte, if we have our battery, and this is my negative terminal and this is my positive terminal, that means that this electrode here is going to be negative. And so it will attract the positive ions. And this electrode over here is going to be positive. And so it will attract the negative ions. And so now we have the movement of charge. And when you have the movement of charge, you have an electrolyte and the light bulb will light up. Okay? But if we have a non-electrolyte, there's no charged particles. So we can stick these electrodes in here, we can turn on the battery, we can have it all up and running, and nothing's going to happen because there's no charged particles in solution to conduct the electricity. I don't know why I'm writing because it's like hardly legible, but I'm trying to do this really fast so I can get you out of here because I know it's been a long, long lesson. So what you're going to do is you are going to circle the compounds that can be expected to form ions. In other words, dissociate. And whose dissociates? That would be your ionic compounds and acids. Which of the substances listed in number 5 would also be called electrolytes? Well, I'm going to let you think about that one. And then finally, for our last question, number 7, you're going to write either the dissociation or the dispersion, and then you're going to decide which one is an electrolyte and which one is a non-electrolyte. So just for next week, we don't know exactly what the schedule is going to be just yet. We will probably find out on Wednesday. So just stay tuned for next week's schedule.